There are two identical engine-driven generators called Integrated Drive Generators, IDG. They are used as the main power source to supply the aircraft electrical network. The IDG basically contains, in a common housing, a generator and a constant speed drive, CSD. The CSD provides a constant input speed to the generator, which is required for a constant output frequency. Each generator supplies 115 volts 400 Hz alternating current, AC, to its own bus. Generator 1 supplies AC bus 1, Generator 2 supplies AC bus 2. This supply is known as split operation. That means the AC power sources are never connected in parallel. Each AC bus supplies a transformer rectifier, TR. AC bus 1 supplies TR1. AC bus 2 supplies TR2. The TRs convert 115 volts AC into 28 volts DC to supply their associated DC buses DC1 and DC2. DC bus 1 then supplies the DC BAT bus. The DC battery bus can charge the batteries or receive power from the batteries as a backup supply if no other power sources are available. The electrical system also includes two essential buses. One is the AC essential bus fed by AC bus 1, and the other is the DC essential bus fed by DC bus 1. These buses are used to supply the most important aircraft systems. This is the basic electrical system. We will now introduce some other components which also supply the system. The entire electrical network can also be supplied by the APU generator. On the ground, the aircraft electrical network can be supplied by an external power source. Any one of the power sources can supply the entire electrical network. As no parallel connection is allowed on this aircraft, split operation, we have to give priorities to the different power sources in supplying the bus bars. AC1 and AC2 buses are supplied in priority by their own side generator, then the external power, then the APU generator, and then by the opposite generator. The electrical system is also fitted with an essential transformer rectifier, essential TR, which supplies the DC essential bus in abnormal or emergency configuration. In abnormal configuration, loss of TR1 or TR2, the essential TR is supplied by the AC essential bus. The hydraulic power to drive the emergency generator is provided by a ram air turbine, RAT, via the blue hydraulic system. The RAT is located in the belly fairing and extends in case of severe electrical or hydraulic failures. We will see the RAT activation later. In emergency configuration, loss of AC bus 1 and AC bus 2, the essential TR is supplied by the emergency generator. In emergency configuration with emergency generator not available, BAT 1 supplies the AC essential bus via the static inverter, and BAT 2 supplies the DC essential bus. You can see that all the components we have talked about are displayed on the ECAM page. Notice that each component has a title to aid identification. Gen 1 and Gen 2, supplying AC bus 1 and AC bus 2, TR1 and TR2, supplying DC bus 1 and DC bus 2, two essential buses supplied by the corresponding main buses, the DC BAT bus and two batteries. For simplification, the component indications have been removed. Let's now present them. As shown, each component can be monitored via its indications. The electrical panel is located on the overhead panel. On the 318, a commercial push-button switch is added on the electrical panel. For emergency cases, there is an EMER Elec Power panel on the left-hand side of the overhead panel. Now, let's look at the relationship between the electrical panel and the ECAM electrical page. The battery voltage can be monitored either on the overhead panel or the ECAM page. Each battery is controlled by a push-button switch. Both main generators and the APU generator are controlled by their associated push-button switch. The external power is also controlled by a push-button switch. The AC essential feed push-button switch enables the pilots to change the supply for the AC essential bus from AC bus 1 to AC bus 2. When the bus tie push-button switch is in auto position, it allows the opening or closing of the bus tie contactors in order to supply the AC1 and AC2 buses according to the power supply priorities. When off, both bus tie contactors open to isolate one side of the network from the other, e.g. smoke configuration. In case of failure, these push-button switches disconnect the IDG from the engine gearbox. The commercial push-button switch allows the shedding of galleys, cabin and commercial-related loads. The emergency generator test switch is used to test the emergency generator. In avionics smoke condition, the Gen 1 line push button disconnects the generator from the bus bar, but it remains energized to supply fuel pumps. Manual on push button. The RAT is automatically extended by the system in case of loss of AC1 and AC2 buses in order to pressurize the blue hydraulic system. Then the emergency generator automatically supplies the essential network if its parameters are correct. Note: the RAT may be extended manually by pressing the red guarded Manual On push button. The RAT plus emergency generator light comes on red when the emergency generator is not yet online, transient configuration about 3 seconds, or generator faulty. The static inverter converts the direct current from battery 1 into an AC current if no other source is available. The battery charge limiters, BCLs, control the battery coupling and uncoupling to the DC battery bus to ensure battery charging and protection. Each battery is rated at 24 volts with a capacity of 23 ampere-hours. All TRs are identical and interchangeable. The Ground Power Control Unit, GPCU, connects the external power to the aircraft network if all parameters are within the limits. It is also the central unit connected to the centralized fault display unit for on-board maintenance purposes. The Electrical Generation Interface Units, EGIU, used by the ECAM to display the AC electrical power parameters. The Generator Control Units, GCUs, protect and control the aircraft network and generators. The main CB panels are located in the cockpit. In the EEP-GS, the GPCU is replaced by a Ground and Auxiliary Power Control Unit, GAPCU. The GAPCU controls the APU generator and the external power channels. The essential TR is identical to TR1 and TR2. It converts 150 volts AC to 28 volts DC at a rate of 200 amperes. The emergency GCU connects the emergency generator to the essential network if all conditions are met. The Ground Power Control Panel, GPCP, and the external power receptacle are located in front of the nose landing gear. On this panel, 2 lights indicate the ground power unit availability, avail light, and connection to the aircraft network, not in use light. The ground power unit should provide 400 Hz 3-phase 115 volts AC rated at 90 kVA minimum. The maintenance bus switch, located on the forward cabin CB panel, allows the AC and DC service buses to be supplied without energizing the whole aircraft electrical network. The aft cabin CB panel contains only CBs. The RAT will extend automatically to pressurize the blue hydraulic system, which powers the emergency generator, if the aircraft speed is sufficient and AC bus 1 and 2 are no longer supplied. Caution: the RAT will extend also if the red guarded manual on push button is pressed, even if the aircraft is not electrically supplied. Cold aircraft. The GPCU is the interface between the GCUs and the CFDIU for test purposes and fault reporting on the MCDUs. Both the BCLs and the emergency GCU communicate with the CFDIU for the same purposes. The TRs are connected to the CFDIU so that they can be reset via the MCDU. In the EEP-GS, the GAPCU is the interface between the GCUs and the CFDIU for test purposes and fault reporting on the MCDUs.